Right, for those of you who are interested in finding the sheets and working out, they're in a new page. It's in the Pure Maths section under Integration for Differential Equations. The link to the notebook is in OneNote. Sorry, not in OneNote, is on the link on the YouTube channel. So, first thing we need to do when we solve a differential equation is we need to get the x and y on each side by either multiplying or dividing. So let's first do that. So we're going to get the y on this side by dividing by y. So we get 1 over y times by dy by dx equals 2 open brackets 1 minus x. So we've separated the variables out and we've got the y and the x's on each side. The next thing we need to do is we need to separate out the dy by dx as if it was a fraction. Now, this is not normally the way I teach this. Okay, I normally encourage people to integrate both sides with respect to x, but for purposes of just getting it done in the test, you can just think of this as a fraction and bring the dx over here. So 1 over y dy equals 2 1 minus x dx. And then all we do is we integrate both sides. So we put the integral sign there, put the integral sign there, and we're ready to integrate this. So we'll get on with that integral, and we integrate 1 over y dy, and we get natural log of y. Integrate this side, and we're going to get 2x. Integrate this, we're going to get minus x squared, and we get the constant. Now note that we put the constant only on one side. We don't need it on both sides. We just need it to be on one side, because actually if we had, say, let's say we had two constants d and we had c, if we take d away from c and get another constant called b, then we're down to our one constant. So therefore you can see you only need one constant on one side. Let's just rub that out and put a proper x in there. I was going to write a 2 by mistake initially. So we've got natural log of y equals this. So if we raise both, we want to get the answer in the form y equals f of x. So if we raise both sides to the power of e, so this side to the power of e will just go to y. This side to the power of e is 2x minus x squared plus c. Now, what we can realize is this is just the same as y equals e to the 2x minus x squared times e to the c. Now, e to the c is just another constant, so we could just write that as ya e to the 2x minus x squared. Now, ironically, that doesn't actually save us anything when we come to get our final equation out, and we end up putting it back in, but generally that's the way we go about doing these. That's why I've showed you that at this stage. Anyway, we put x equals 1 and y equals 1 to find out what a is, what our constant is. Or we could have put it in this stage to find c, or in this stage to find c, or even this stage to find c. You can put these values in and find your constant. I'm going to put them in now. So I'm going to get at x equals 1, y equals 1. I get 1 on this side, equals a times e to the 2 times 1 minus 1, which is e to the 1. Just want to make sure I got that. Yeah, equals e to the 1. So therefore I get a equal to e to the minus 1. So what we've got here is we've got y equals a e to the minus 1 times e to the 2x minus x squared. And actually it's probably better written, ironically, as e to the minus 1. Remember, when you're timesing, you add your indices, so that minus 1 ends up just there. Which is what would have happened if I'd bothered to put in the constant at any stage where I got plus c. I'd have ended up with that. So I'd have got to the answer more quickly. But generally, this is better than this format here. Okay? Right, moving on to our next question, which I'm going to probably give you. I think I'm going to give you 3 minutes to have a go at the next question. It's a little bit more involved. So let's get on with that one. Okay, so we're out of time. So remember what we're going to do. We're going to first of all get all the x and y terms on the other side by multiplication or division. So that's the first thing we've got to do. Now, this is effectively our y term here, and that's our x term. Remember, do y with x what it normally has. So therefore, that n needs to be on the other side by dividing. So we're going to get 1 over n dn by dt is equal to minus k. And then what we're going to do is we're going to separate our derivative out as if it was a fraction. So 1 over n dn equals minus k dt, just multiplying that across. And last but not least, we're going to integrate both sides. Okay, and that's our 3-step way to doing differential equations. So carrying on, let's do the integration. So we get natural log of n will equal minus k t, integrating this with respect to t, plus our constant. Raise both sides to the power of e. I'm just going to write it in like this, just for a different way of writing it, just so you can see more of the working. And we can see e to the natural log of n is just n. Okay, they're inverse operations. Now, what we realise, we've got e to the minus kt times by e to the c here. And this is effectively a constant, so we're going to call that a, where a is equal to e to the c. And that's how we get the a into this. So as I said, we often do it this way. Now, what we're going to do something a little bit more tricky now. So 5 minutes for this next question. Off you go. Right, you'll notice there's a little plus here you have to deal with before you can start doing the timesing and dividing in this question. So that's my tip for this question. Right, so let's just have a look at this question. So let's remember what we've got to do first. We have to get all the x terms on one side and the y terms on the other side by multiplication or division. But the only problem is we've got this plus 4 here to deal with. So we have to deal with that first because we can't divide in times to get the dy by dx on its own with just a multiple of x or y. So we get rid of that plus 4. So let's deal with that. So this one I've thrown in here, so as you can see there is an exception to our rules. So we take 4 away from both sides. Now we're going to divide because we need the y's on this side and we need the x's on the other side. So let's get 1 over y squared minus 4 dy by dx equals 1 over x, dividing this side, both sides by x and both sides by y squared minus 4. Then we're going to split up the dy by dx like a fraction. And then we are going to integrate. Okay, and if you do it this way, no one will notice in the exam that you've done it in that noddy way and it's not actually doing it. Normally I'd say integrate both sides with respect to x right here, and then you cancel out and get this. Now the only thing is with this integral is we've got this 1 over y squared minus 4, and what you've actually got here is a partial fractions question hidden inside your differential equation question. And effectively this is the same as y, oops, I've written an x, y minus 2, y plus 2. So we're going to write y minus 2 there, and we're going to put b over y plus 2. I'm just going to rub this out now because it's in the way. So we got 1 will equal a times y plus 2 plus b times y minus 2. Okay, if you're not sure why that's so, you need to go back and do a lesson on partial fractions. Okay, so next thing we're going to do is we are going to let y equal to minus 2. And that will make this 0, and that means we can find out what b is. So if y is minus 2, we're going to get 1 equals minus 4b. So b will equal to minus a quarter. And if we let y equal 2, then this bit becomes 0, and we get 1 is equal to 4a. So we get a quarter is equal to a. So this side now becomes the integral of, what I'm going to do is actually I'm going to take out a quarter here, just to make my integration easier. And I'm going to put the a bit, we've got the a bit here, so we're taking out the quarter, so we've got 1 over y minus 2, so we take out a factor of a quarter, minus, and we're going to take out a factor of a quarter, so it's just going to be minus 1 lots of this, 1 over y plus 2. And it just makes everything a little bit easier when it comes to do the integration. So we integrate both sides. So I'm actually going to take this quarter and put it over here and times by 4. So this will just become the natural log of y minus 2. And this will just become minus the natural log of y plus 2. Equals 4 times the natural log of x plus. And we've got 4c, but we don't really need to have 4c because that's just another constant. So I'm just going to make that c right off the bat. Now, let's just give ourselves a little bit more space. Let's scroll this down. Let's have a space. Alright, so we've got, this is just equal to natural log of y minus 2 over y plus 2 is equal to, I think the best thing to do here is natural log of x to the 4 plus c, using that log law. So anything times by the natural log of x is the same as natural log of x to that power. Now we can do our e bit. So if we raise this to the power of e, we get y minus 2 over y plus 2 equals. Just going back to the question just to find out what we're supposed to be doing. We don't have any values. We're just going to get it y equals format. So we need to get y on its own. And I'm going to need even more space to do that, I should think. So let's just get myself a bit more. So I'm going to have e to the natural log of x to the 4 plus c. So that's just going to be the same as e to the natural log of x plus 4 times e to the c. E to c, remember, is a. So I'm just going to write this as a times e to the natural log of x plus 4 is just x plus x to the 4. I'm just going to write that out to the side for those of you struggling to cope with all that in your head at once. So this is the same as e to the natural log of x plus 4 times by e to the c. Because you've got the plus in here, remember you add the indices when you got this. E to the c, I'm just going to replace with an a. Okay, so I've got a times that. Let's put the a at the front. Then e undoes the natural log, so we're just left with ax to the 4. So what I'm going to do now is I'm going to times by y plus 2. And get even more space. Probably not enough, actually. Let's just see if we can grab a bit more. We're nearly there. Multiply out the brackets. So I'm going to get y(a)x to the 4 plus 2(a)x to the 4. And now I can get all the y's on the same side. So I've got y minus y(a)x to the 4 minus 2. I'm going to take the 2 to the other side. 2 plus 2(a)x to the 4. Now I can factorize this out. So I've got y, open brackets 1 minus ax to the 4. I'm just looking in the chat, notice a question about what are Edexcel planning for these mini tests. We don't know what Edexcel and OCR are planning for these mini tests until we actually get them. So once we get them, we'll know better. And what I'm doing with my sets is planning as if it was a normal A level and normal difficulty. And then if you come up with, if you do that, nothing is going to surprise you. And you'll be sorted. So we get divide throughout by this, and I've just written that in the wrong order. Okay, so there we go. Y equals 2 plus 2ax to the 4 over 1 minus ax to the 4. We don't know what a is, and we're not being given any initial conditions in our question if you go back here. So therefore, we leave that in our final answer. Okay, next question is also quite a biggie. I'm going to give you, it is doable in 5 minutes, I can tell you that. I've had a go at it earlier today for the first time without seeing it. So let's give you 5 minutes. You should give you enough time to at least have a really good go at it. There we go. Pardon? Just doing a full time. But have I got another E question coming up? Let's look. They're very common, these E questions. Unfortunately, it's not. Well, actually, I can sort of go over it. I've got two more questions. This is bringing in 2 topics and a bit of problem solving. Let's give some hints. Right. I didn't untoggle that. Sorry. Just repeat that again because the mic wasn't untoggled. What I was saying, you've got dv by dt here. You can also, but you need dh by dt. So you're going to use chain rule by getting dv by dh from the information in the question. You should know what the volume of a cone is. We need the volume at a point in time, and you need to get the radius in terms of h at any point. and realise that h and the radius are always in the ratio of 4 to 10. If you can't see how to prove this, how about you just solve the differential equation from here? Right, so here we go. We've got this question and we're going to try and show this to start off with. Now, if you can't show this and you're in a test, just have a go at solving the second half of the question, okay, by solving this differential equation. Anyway, the first thing you've got to realise, this is dv by dt. So we write dv by dt is equal to 80. How do I know it's dv by dt? Well, that's volume, and that's time to the minus 1. There's volume over time, so that's dv by dt. What I also know that is I've got the radius at this point in time is going to be in ratio h over 10 times 4. Okay, because if I've got h at any point in time, okay, and this is 10 tall and this is 4 wide, then this radius r will equal h over 10 times 4. So when I'm working out my volume equation, I know that the volume is equal to a third times by the height times by the base area, 2 pi r squared. And I know that r is equal to 4h over 10. So therefore, I'm going to get 1/3 times 4. Sorry, left out the 2, didn't I? And the area is not 2 pi r squared. I don't know why I wrote that. Confusing two different formulas at once. Sorry about that. Let's just rewrite that. So h times pi r squared. So we'll just write that in with this as 4h over 10 all squared. So therefore we're going to get 16h cubed times by pi. I would normally put the pi before the h, but I've written the h down. 10 squared is 100, so it's 300 on the bottom, times by the 3. So I know that v equals that, and now I can find dv by dh. dv by dh times this by 3 times by the power. That'll cancel out with the 3 on the bottom. So I'm just going to get 16h squared. Put the pi in here because I like it there better. Cancel out the 3 with and leave 100 on the bottom. So I've got dv by dh. So now I can find dh by dt. Now dh by dt is equal to, let me think, dv by dt times dh by dv. So it's equal to this one divided by this one. So it's equal to 80 times by, I'm going to not write divide, I'm going to write times by and reciprocate it. Okay, so I'm going to turn this upside down. 100 over 16 pi h squared. So times this by the pi h squared to get dh by dt is equal to, and when we cancel this all down, we get 500. Right, just scroll, get myself some more space for the next bit of the question. So now we're going to solve this differential equation because we've given the cone initially empty. How long does it take to fill it? Okay, so what we're going to do is we're going to solve this differential equation. And how do you know you've got to solve this differential equation? Well, they're giving you a differential equation to find. They say it's a differential equation. What's the point of giving you a differential equation if you don't solve it? So let's do that. Now we want all the, normally we want all the h's on this side and all the t's on the other side, so that's nice. So it's actually going to be quite easy to do. Remember, we're going to separate out the fraction. You know, we've done, part 1's already been done for you, so we're on to part 2. We just separate out the fraction, so we can get dh equals 500 dt. And then all we've got to do is integrate it. And the call out goes over my working, so let's get rid of the call out. There we go. So you can see all the workings. So we've got pi h squared dh by dh equals 500 dt. I'm now going to go over here so I don't end up writing behind my head. So integrate this side. I'm going to get pi h cubed over 3 is equal to 500 t plus some kind of constant. Now we know that at t equals 0, h will equal 0, therefore c will equal 0. 0, 0, 0. If you times anything by 0, you get 0. So we want to find out how long it takes to fill it. Well, it fills when h is equal to 10. If we look back at the question, we can see h is equal to 10 just here. So we're going to put h equal to 10. So we get pi times 10 cubed over 3 is equal to 500 t. Rearrange that, and what do I get t? I get t is 2 pi over 3 seconds. That's my answer when I rearrange all that. So you work that all out. So you got 1,000 over 3 divided by 500. Well, that's 1,000 over 1,500, which is just 2/3. Okay. Right. Next. Well, what's the question you had, Claudia? A second ago. Oh, about the E. Right. There's a good question about the E's I'm going to come back to when we get another E question. So, next question is another long one. Give you 5 minutes to get stuck into it and see how you do with that. Right, you should be getting to the stage where you should easily get through the partial fractions, and you should hopefully have separated out the variables and got started on the integration. Let's see how you did compared to this. So you may want to carry on with the integration while I go through the partial fractions if you're quite certain you've got the partial fractions right. But if you're not too sure about the partial fractions, we're going to make it equal to a over 2x minus 3 plus b over x plus 1. So therefore 13 minus 2x will equal a times x plus 1 plus b times 2x minus 3. And do remember, all the partial fractions we've done here today are just the standard ones. There's two other special conditions that most boards expect you to be able to do. So, and if you don't know, if you think to yourself, what are those two special conditions, then you better go and revise them. X equals, well, depending on, again, what your school wants you to cut out. X equals minus 1. We're going to get, what's that, 15 here? That will give you 0, and that will give you minus 5. And we get lots of b, and here we get minus 3 equals to b, which is not what I got the first time I did it. It led to some really interesting answers in the second half. But then I noticed I got interesting answers in the second half, and I go back and correct this. So let x equal 3 over 2, that all becomes 0. And then this becomes 5 over 2, and this will become 10. So what do we got? We've got 10 equals 5 over 2 times a, so therefore a will equal 4. So let's get into this part of the question. I suppose I ought to actually write out the partial fractions. So the partial fractions we're going to get actually are 4 over 2x minus 3 minus 3 over x plus 1. Okay, let's do this. Remember what we're going to do, number one? We have got to get our x and our y's on separate sides by dividing or timesing. We're going to divide by y. So we get 1 over y dy by dx is equal to 13 minus 2x over 2 minus 2x even, minus 3x plus 1. There we go. And next, we're going to separate our dy by dx out like a fraction. And while we're at that, we may as well put this into its partial fractions. That'll save us some space later. We know we're going to prefer to integrate these to this. And we get our dx over here. And last but not least, we are going to just put our integrals in. Okay, let's just find a little bit more space to write this answer out. So I'm going to scroll that down, get rid of question 6. This is an Edexcel question. The next question is an OCR question, for those of you who are interested. Integrate this, we get natural log of y is equal to, now this is going to be 2 natural log of 2x minus 3, because when you differentiate this, you get a 2 coming out to go on the top, but we got 4, so we need 2 times that. Now we have got 3 times natural log of x plus 1 here. If you need to work out more of these, I suggest you go and find a textbook and practice these if you're not getting these right. Okay, and we add on our c on the end. Now we know y equals 4 when x equals 2. I've got lots of logs here, so I decided actually not to mess around with this c and all the algebra. I'm going to find out what c is to make my life easier. I think that's what will happen now. So hence, sometimes you'll notice I leave c to the very end to work out, or sometimes I work it out earlier, depending on what I feel will make my life easier. Now, if I've got x equals 2, this is just going to be 2 times 2 is 4, minus 3 is 1, natural log of 1 is 0. So I'm going to get minus 3 natural log of 2 plus 1 is 3, plus c. So c will equal natural log of 4 plus, let's bring this up as a power, natural log of 3 cubed. So that's 27 times 4. I think that's 108. So c is natural log of 108. And we're still going to need even more space to this question. So what we got here, we've got natural log of y equals, well, I'm going to just bring this up as a power now. Natural log of 2x minus 3 squared. I'm going to bring this one up as a power as well. Natural log of x plus 1 cubed plus natural log of 108. Now, I can't really, well, I can raise this as powers of e's right now, but if I got e to all of that and then I got e to all of that, it's a bit of a mess. Let's just wait a moment before doing that. So what we're going to do is I'm going to bring all these natural logs together, and natural log of one side equals natural log of another side. That makes life a bit easier. So I'm going to divide by this because I've got a minus. I'm going to times by the 108 because I've got a plus. Those are your natural log laws. If you don't know those natural log laws, then you need to go away and find the right chapter in the book on natural log laws and practice those. And I'm going to divide by the x plus 1 cubed. I'm dividing by the x plus 1 cubed because there's a minus there. I'm timesing by the 108 because I've got a plus here. Now I can just remove the logs. Effectively, I'm doing e to all of that, and e to all of that removes the logs. If you want to know what the inverse function that does that, so get all that squared over all that cubed. And there we go. Our thing y in terms of x. I think, yes, let's give you a answer in the form y equals f of x. So I've got a question in the classroom. Yes. How come I've got ln 2x minus 3 here? Oh, from the 4. Well, what you'll realise, if you differentiate this, so the question is, how come I've gone from there to there? So I've got natural log of 2x minus 3. Now, if you remember, if your chain rule differentiation, you differentiate the inside, you'll get a 2 coming out. And then you differentiate the natural log, you'll get times by 1 over 2x minus 3. This is the u bit. Okay? So you get 2 over 2x minus 3 bit. But we want 4. So we need double that. So therefore, double this will be the thing I differentiate to get 4 lots of that. And therefore, integrating, I only need the 2, not a 4. And it's because of that little 2 there. Okay, that little 2. When you differentiate 2x minus 3, you get the 2 coming out. If you're still struggling with that, I suggest you go back and do some more chain rule differentiations, especially ones of the type natural log equals f of x. Because what you should realise is natural log of f of x differentiates to get f dashed of x over f of x. And if you've got a multiple of f of x, a f of x, then you'll get a f dashed of x over a f of x. And you've got to take that into account. But because I've got 2 and I've got 4 here, it's not quite the same. So I've got to have an extra multiple in there. Let's rub that out. And let's move on to the next question, which is an OCR. So we know it's going to be lots of problem solving. Shane, I'm only going to give you 5 minutes to have a go at it. Sorry, last question of the day for those of you wondering out there in the ethers. Okay, so tricky one to finish off with. Well, it's not. If you know what to do, it's not very tricky at all. It's actually one of the quickest ones to do if you know what to do. So we've got in the year 2000, the population density P of the village was 100 people per kilometres and was increasing at a rate of 1 person per kilometre per year. So did P-body at this moment in time, so year 2000, sorry, I just need to get a pen, I got rubber for some reason. So at the year 2000, we know that dp by dt at that point in time was equal to 1. And we know that P was equal to 100. The rate of increase of population density is thought to be inversely proportional to the size of the population density. So dp by dt is thought to be inversely proportional. So it's k over the size of the population density, P. And the time in years after the year 2000 is denoted by t. So 2000 is when t equals 0. So we know that t equals 0 at this point in time. So we know at the moment t equals 0, p equals 100, dp by dt equals 1. So we know that 1 equals k over 100, so k equals 100. So we now can write out that dp by dt is equal to 100 over p. So that's the sort of problem-solving-y bit. Now we just get into a rhythm of what we do with our differential equations. So we get all the x terms on one side and all the y terms on the other side by multiplication or division. But in this case, well, that's our y and that's our x. P is our equivalent y, t is our equivalent x. So we need the p over here. Whatever's on the top is what you need over here. So we're going to times by p. So we get p dp by dt is equal to 100. And then what we do is we just separate out the dp by dt as if it was a fraction. So we get p dp is equal to 100 dt. And then all we've got to do is just integrate that. And I'll just remove the call out. Integrate both sides to get that. Let's just scroll that up so you can see it because it's not behind my head. So we've got the integral of p dp by dt equals the integral of 100 over to t. Now, just so we don't go behind my head again, let's go over here. So integrate p dp, that's going to give me p squared over 2 equals 100 integrated with respect to t is 100t plus c. What else do we know now? We know t equals 0, p equals 100. So we can, so t equals 0, p equals 100. Write that in. So we get 100 squares, 10,000 divided by 2 is 5,000 will equal 0 plus c. So c equals 5,000. So our equation here is p squared over 2 equals 100t, plus c, plus 5,000 even. Did they ask for it in p as f of t? Let's have a look. P in terms of t, they did. So we're going to times by 2 and then square root. So we get 200t plus 10,000 square rooted. Now, part 2. In 2008, the density of the village is 108 kilometres squared. And in 2013, it was 128 people per kilometre squared. So let's look at 2008 because it wants to see if our model's any good. So t will equal 8. So p will equal the square root of 200t plus 10,000. And I'm going to just replace that t with an 8, obviously. It's a bit dumb to write the equation out again. So we get that, and I think I got that equal to 107.7. So it's okay, because that's quite close to 108. So a good fit for 2008. Now, when 2013, we've got t equals 13, p equals the square root of 200 times 13 plus 10,000. And I'm just going to get my calculator out to do this because I wasn't sure that my answer is necessarily correct. So we're going to do shift square root, put some brackets. Oh no, I don't need the brackets because it's going over all of it. 200 times 13 plus 10,000. Work that out and it gives me that, which is 112.2. So I did get it right the first time. So that's equal to 112.2. Now, in reality, it's 128. So, good model for t equals 8 up until this point in time. Poor model now. So overall, we'd probably say it's a poor model. Okay, and that's the end of today's session on differential equations. What I suggest you do, if you can't do those in that amount of time, you'll only be able to do those in those amount of time if you really know your stuff well, and you're basically looking at A grade, A star standard on this topic in itself. The way to do it: wait till your Easter holidays, watch the stream again in the same amount of time, and see if you can do the questions in the time then, having had a bit of a break and hopefully knowing what you do. If you don't, do it a second time. Okay, thank you, and we'll do another one next week and see you then.